I would like you to pause the video, try to solve the answer, question, and then you can play the video. Okay, let us first understand what the sum is asking us to prove. So let's say this is a quadrilateral A, B, C, D, and we have midpoint. So this is P, Q, R, and S. So the question is asking us to show that the line joining midpoints of opposite sides. So what does that mean? So I have to join PS and PR. Okay, so I have to join PR. Let us say they meet at some point O. So what are we supposed to show? That they bisect each other. So bisect each other as in this. Okay, so this is what you need to prove. Give it a try. Okay, so I've drawn the diagram over here. What I've done is ABCD is a quadrilateral and PQ RS are the midpoints of the sides, and we have to prove. Okay, so let me write over here to prove that PR and PQ bisect each other. Okay, so we need to prove that PR and PQ bisect each other. So for that, what I'm going to do is I'm going to consider triangle ABD. In triangle ABD, P and Q are midpoints of AB and AD. Okay, so what is the reason for that? This is given to us. Therefore, what does it tell you? It tells you that PQ is equal to half of BD, and it tells you that PQ is parallel to BD. And what is the reason for this? The reason is midpoint theorem. Okay, now the same thing can be done for the other triangle, triangle BCD. In this, you have S and R are the midpoint of BC and CD. Okay, this is also given. So we get SR equal to half of BD. We get SR parallel to BD. Okay, again, the reason is midpoint theorem. Now, if I call this point as number 1, if I call this point as number 2, so from point 1 and 2, what do I get? From 1 and 2, I get PQ is equal to SR, and I get PQ parallel to SR. And this can be called as my point number 3. So from point number 3, what do I get? I get that this quadrilateral is a parallelogram. So from point number 3, we get PQRS is a parallelogram. Are you understanding? Now, why is it a parallelogram? Because one pair of opposite sides are equal and parallel. So now look, what is PQRS? So PQ, R, and S is a parallelogram. How did I prove it? I prove it using the property that one pair, in this case PQ and RS, are equal in length and they are parallel to each other. And we have to prove that PR and PQ bisect each other. That's another property of parallelogram. And what is that property? That property is that the diagonals of parallelogram bisect each other. Okay, the diagonals of parallelogram bisect each other. So therefore, I can say that PR and QS, okay, this I will make a correction. This is SQ. Okay, so PR and QS bisect each other. What is the reason? Because they are diagonals. Why? Because they are diagonals of a parallelogram. Okay, so this is the proof. Let's move to the next question. So this is our next question. I would like you to make a figure and then see how you can prove this. Okay, so pause the video, give it a try, and then play it again to see how it is solved. Okay, so let's start by drawing the figure. ABCD is a rectangle. So let me draw that as a rectangle. So here it is a rectangle. And I'm going to name it. So I have A, B, C and D over here. Okay. Now P, Q, R, S are the midpoints. So let us label the midpoints here. So PQ, so this is P, this is Q, this is R and S. We have to show that they form a rhombus. So by a line joining them, so P joining to S. Okay. So how do we go about it? So I'm going to join the diagonals as well. Now in the previous question, we have proved one thing, and that is we are going to get PS. Okay. So we got PS equal to half of BD, and we got PS parallel to BD. Okay, so we did that. We also proved that QR is equal to half of BD, and we got QR parallel to BD. This led us to PS equal to QR and also PS parallel to QR, which then led us to the property that PQRS is a parallelogram. Okay, so you're very well aware. This is what we did in the previous question. Now what I can do is I can draw the second diagonal here. Okay, so let me draw the second diagonal, and that is AC. So after drawing the second diagonal, I can repeat the process with this. Okay, let me just erase it, this diagonal, to make it more clear to you. So we can show that PQ, okay, PQ is half of AC. We can show that PQ is parallel to AC. We can show that SR is equal to half of AC, and we show that SR is parallel to AC. Okay, but why I'm doing this? So I would like you to pay attention to this part. So we have PS, okay, parallel to a half of BD. We have PQ, half of AC. But my question to you students is, what can you say about BD and AC? So let me draw BD now again. So what can you say about BD and AC? They are equal. Why are they equal? Because they are the diagonals of a rectangle. Okay, because they are diagonals of a rectangle. Okay, so what do we have? We have PQRS is a parallelogram. Okay, we have BD equal to AC. We have PS half of BD, and we have PQ half of AC. Therefore, we have PS equal to PQ. Now, what does that lead you to? It leads you to a property that this is a parallelogram, okay, but its adjacent sides are equal. So a parallelogram whose adjacent sides are equal will become a rhombus. So therefore, PQRS is a rhombus. Okay, PQRS is a rhombus. So we first proved PQRS to be a parallelogram, and then we proved that adjacent sides of this parallelogram are equal. That makes it a rhombus. Okay, now we move to the next question. So this is your next question. Again, pause the video, give it a try, and then we will discuss the solution. So the information provided over here is AB is parallel to DC, and the line passing through E, which is a midpoint, is also parallel. Okay, I'm going to do one construction here. I'm going to join this, and let us name this particular point, say a point P. Okay, now in triangle ABD, I have E as a midpoint of AD. E is midpoint of AD, and I have EP parallel to AB. I can say that both the things are given to us, and therefore I can say P is midpoint of DB, and the reason would be converse of midpoint theorem. Okay, so now I have got P to be the midpoint. Right, now we look at triangle DBC. In this we have P is midpoint of DB, and we have PF parallel to DC. Okay, both these things. So P is the midpoint of DB is proved, and this part is given to us. So again, we have F is midpoint of BC, and the reason is converse of midpoint theorem. We had to show that F is a midpoint of BC, and we have proved it. Okay, let's go to the next question.